Hello everyone, I'm Jonathan R. Abanilla from BSCE 4B. So I'll give you some example for the steel design in flexural members. So first situation is determine the nominal flexural strength of a W14 by 68 grade 50 subject to continuous lateral support. So the properties of W14 by 68 is here. BF is equal to 254 mm, the TF is 18.3 mm, D is 356 mm, the thickness of web equals to 10.5 mm, the K is equal to 33.3 mm, the H equals to D minus 2K, si RY naman natin 62.3 mm, H sub O equals to D minus TF, ZX is equal to 1880 times 10 raised to 3 mm cube, si SX natin is 1690 times 10 raised to 3 mm cube, si IY naman natin is equal to 50.4 times 10 raised to 6 mm to the fourth, si J natin is 1250 times 10 raised to 3 mm to the fourth. CW natin is 1140 times 10 raised to 9 mm to the 6. So, si FY ng A572 natin is 344 MPa. So, solution. So, una, pupunta tayo sa table 501.4.1 para makita si limiting width thickness ratios for compression element. So, una, tingnan natin yung for flanges. So, flanges to. So, flexure in flanges of rolled eye-shaped section and channel. So, case 1 yung gagamitin natin. So, una, kunin natin si width thickness ratio. Width thickness ratio ni case 1 is yung lambda natin is equal to BF over 2F So, 2TF. So, ayan. So, si BF natin, substituting the values, 254. Si BF natin is 254 over 2. At si TF natin is 18.3. So, equals to 254 over 2 multiplied by 18.3. So, equals to 6.94. 6.94. And for the compact ng case 1 natin, or the lambda P, for lambda P natin is equals to 0.38 square root of the E, or the elasticity, elastic modulus, and the Fy, so equals to 0.38. So si E natin is 200,000 over si Fy naman natin, eto 344 megapascal. 0.38 square root of 200,000 over 344, so equals to 9.16. So, next naman is si lambda R4 non-compact ni case 1. So, for lambda R, meron tayong 1.0 square root of E over Fy. So, 1.0 multiplied by 200,000 over 344. So, equal siya sa 1.0 square root of 200,000 over 344. So, equal siya sa 24.11. So, ibig sabihin, si lambda natin is less than lambda P. Ibig sabihin, the flanges is compact. So, next naman is kunin naman natin yung sa web niya. Sa web. So, punta ulit tayo sa table 501.4.1. So, hanapin ulit natin limiting width-thickness ratio for compression element. So, flexure in webs of doubly symmetric I-shape, section, and channels. So, makita natin doon si case 9. So, for case 9, si case 9 natin is yung lambda natin doon is equals to H over TW. So, si H natin, dahil dito, si H natin is D minus 2K. So, si H natin is D minus 2K. So, equals to, so si CD natin is 356 mm minus 2 at si K natin is 33.3 mm over sa TW natin, thickness of web is 10.5 mm. So, by calculating, 356 minus 2 multiply by 33.3 over 10.2 ay 10.5. So, equal sa 27.56. 27.56. And next naman is si lambda P for case 9. So, dito case 1 to Case 1 for the flange. And ginamit din natin dito is case 9 for the web. So, lambda P. Lambda P natin dito for web is 3.37. Ay, mali. Sorry. 3.76 pala. 3.76 multiply by square root of E over Fy. So, equal siya sa 3.76 multiply by 200,000 over sa Fy natin is 344. So, equal sa 3.76 multiply by 200,000 over 344. So, equals to 90.66. And the lambda R for the non-compact is equals to 5.70 multiplied by E over Fy. So, 5.70, si E natin is 200,000 over 344. So, equals to 5.70 square root of 200,000 over 344. So, may makuha tayo na 137. 37.44. So, dito is si lambda is less than lambda P. So, ibig sabihin, the web is compact. So, dito naman, makikita rin natin dito na si lambda is less than lambda P. So, for compact section, kunin natin si, ano yung pinapako dito? Si nominal flexural strength. Determine the nominal flexural strength. So, kunin natin si Mn. So, Mn ng compact section is equal to Fy Zx. So, by substituting the values, si Fy natin is 344 MPa. And the Zx natin is 1,880 times 10 raised to 3. Times 10 raised to 3. So, gagawin natin kilonewton meter yung sagot, kaya i-divide natin sa 1,000 raised to 2. (344) times 1,880 times 10 raised to 3. So, over 1,000 squared equals sa 646.72 kilonewton meter. Ito yung sagot natin for the nominal fractional strength ng W14 by 68, grade 50. Situation 2. A W14 by 68 steel section with yield strength of 345 megapascal is used as a flexural member. Using NSCP 2015 specifications, determine the FB at 6 meter span. So this is the properties of W40 by 249 steel section. So si BF natin is 254 mm. Si D or depth natin is 356 mm. Si RY is 62.3. Thickness of the flange is 18.3 mm. Si K natin is 33.33 mm. Si IY natin is 504 by 10 raised to 6 mm to the fourth. Thickness of web is 10.5 mm. And the RTS is 71 mm. So sa problem, determine the F si FB at 6 meter span. So first, solve for LC and LU. So si LC natin, meron tayong formula na 200 BF over FY. So 200 multiplied by BF natin is 254 over na square root ng FY. So sinasabi dito na FY natin is 345. So equals sa 200 multiplied by 254 over square root ng 345. So makuha tayo na sagot na 2,734.98 mm. So for LU, meron tayong formula na 137,900 over FYD. Meron pa pala ditong AF. So yan. So 137,900 multiply by AF natin. So yung area. So BF natin is 254 multiply by 18.3. Yung thickness ng flange natin is 18.3. So over FY multiply by D. Si FY is 345. As si D natin is 356. So equals 137,900 multiply by the area. Area ng flange is 254 multiply by 18.3. It's all over the FYD. 345 multiplied by 356 is equals to 5,218.91 mm. So, sinasabi nga dito, determine the FP at 6 meter span. At 6 meter span. Makita natin dito na yung LB kasi natin ito, LB natin is 6 meter. Convert natin siya ng mm. So magiging 6,000 mm. So si LB natin is greater than the LU. So, ibig sabihin, dahil mas malaki siya sa LU, therefore, it is slender. So, for slender, meron tayong dalawang formula. So, ang una is 703,220 cb over the Fy. And yung pangalawa naman, nating formula is 3,516,330 cb over Fy. So, compute natin tong isa. So, alam naman natin, si CB, yung CB natin dito, is equals lang siya sa 1. Dahil walang sinabi sa formula kung anong CB yung gagamitin natin. So, 703,220. CB natin is 1 is equal to, si Fy natin is 345. So, 703,220 multiplied by 1 all over 345. May makukot ang sagot na 45.15. And next, 3516330 multiplied by CB na 1 all over the Fy na 345. So, equals to, ilagay pala muna natin dito. 3516330 multiplied by CB all over the Fy na 345 is equals to 100.96. So, LB, next naman is LB over RT. Kuhanin natin si LB over RT. So, 6,000 over si RT natin is 71. Is equals to 84.51. So, para makuha natin si FB, slender siya, gagamitin tayo ng second degree interpolation. So, nilagay lang natin dito si limiting values na nakuha natin sa kanina. Sa may X. So, si 45.15, si 84.51, and si 100.96. So, in-squared lang natin sila. So, para makuha natin si Y values naman nila, para dito, kinuha natin si 0.66 Fy. And dito naman, is 0.6 Fy. So, tingnan natin. 0.66 multiplied by 345. So, equal siya sa 227.7. So, next naman is 0.6 multiplied by 345 is equal to 207. So, para makuha naman natin si Y, ito na yung lalabas na FB at 6 meter. At 6 meter span. So, para makuha doon, punta lang tayo sa mode. Then, 3, 2, tapos input natin dito si X and Y. So, si X muna natin, si 45.15 squared. At, hindi muna natin ito i-input, mamaya natin ilalagay yan. So, ito muna, si 100.96 squared. So, next, punta na naman tayo sa Y, 227.7 and si 207. So, pag na-input na natin yan, AC, pindutin lang natin si AC, tapos, Shift, Start. Tapos, click natin si 5 ulit, at input natin dito si 84.51 squared. So, nakuha nating sagot is 214.74. Ito na yung ating LB. Ito yung FB. FB natin. FB to FB. ito yung FB natin. FB at LV6 meter is equal to 214.74.